Welcome back, future teachers of the world. There are some things that proportions and similar triangles let us do that are really, really valuable to us. So just to establish where we were looking at similar triangles. We were looking at how if this triangle is similar to that triangle, then whatever these sides were, these were some multiple of those. And that happens to be true whether the two triangles are apart like this or whether the two triangles are together like this. And so it is well established that if we connect 2 points on the sides of the big triangle so that this is parallel to that, then it turns out that these pieces are proportional to those. That A, B, C, D, that A over C equals B over D, or if you like, A over B equals C over D, it does not matter. These proportions hold. Why? Because the triangles are similar. When we have this line parallel to that one, it means that this angle is congruent to that one. They are corresponding. This angle is congruent to that one. They are corresponding. And so we have angle-angle similarity, which means that the pieces in play are in proportion. Specifically, it means that A over A plus C is B over B plus D, and that gives us those pieces. In fact, in particular, it gives us a very interesting result called the Mid-Segment Theorem. And I'll illustrate the mid-segment theorem in the following way. A mid-segment goes from a midpoint of one side of a triangle to the midpoint of another side of a triangle. Those are the same. Those are the same. This is a mid-segment. Well, if those are the same and those are the same, then this is in the ratio of 1 to 2, and this is in the ratio of 1 to 2. By that, we mean that this is some distance, this is twice that distance, this is some distance, this is twice that distance. So we have sides in proportion, and this angle is shared. So by side angle side similarity, the little triangle is similar to the big triangle. And if the little triangle is similar to the big triangle, then this angle is congruent to that one, and this angle is congruent to that one, which means that this mid-segment is parallel to the third side of the triangle. And that's nifty to know. And they're in the ratio 1 to 2. So whatever the mid-segment length is, the opposite side is twice that. So the mid-segment is half as long as the third side of the triangle. All right. So let's do the thing we came here to do. Let's do the thing where we want to figure out how tall the tree is, but we don't want to run a ruler up the tree. Like, that's complicated. So we know that we got somebody standing over here, and we know that the tree casts a shadow, and we know that the person casts a shadow. And we know that we can measure the tree's shadow and we can measure the person's shadow. So maybe the person's shadow is 4 feet long, and we happen to know the person, and the person is 6 foot tall. And then we know how long the shadow on the tree is. Maybe that shadow is 20 feet long. So we don't want to measure the tree directly because it would be dangerous to take a tape measure up the tree, but maybe we can use the fact that this triangle is similar to this triangle, and so these sides are in proportion. Whatever the height of the tree is compares to its shadow, as the person's height compares to the person's shadow. And we know that the triangles are similar because we know that things like this are proportional, and we know that that's a right angle in both spots. So we can set up this kind of a proportion, and we can solve it using the cross multiplication that we learned in Math 141, and the tree is in fact 30 feet tall. This is a way to do indirect measurement because we don't want to measure that height directly. Uh, and so we use some other object whose height we know and some other thing that is proportional about it. And therefore, we are able to measure things indirectly. In the same way that when we're looking on a map and we see that there are a couple of cities on the map and maybe there's a third city over here on the map, and we know that there's some scale that says 1 inch equals 30 miles, and we happen to know what this distance is in inches. Maybe this is 4.2 inches long, and we're looking to find out what the actual distance is between Springfield and Kansas City or whatever. And so we think to ourselves, if 1 inch represents 30 miles, then 4.2 inches represents some distance m, and we can do the cross multiplication thing and get that the distance between those cities is 126 miles. We measure indirectly. We're not going to run a tape measure from Springfield to Kansas City, but we could run a ruler from Springfield to Kansas City on a map, and that would be a way to use proportions to help ourselves out. I hope that this has been helpful to you. I will see you when we gather.